Hi everyone, I am Aditay Tripathi and today I am going to talk about my work titled Grounding Scene Graphs and Natural Images via Visio-Lingual Message Passing. A scene graph is a rich, structured data structure representing visual semantic association between the objects in the image. And in this work, given a query scene graph and a natural scene image, we want to localize all the objects satisfying the corresponding visual semantic relations. One easy way to solve is to ignore all the relations and use the predictions of the faster RCNN to localize the specific objects. But localizing specific instances of objects becomes harder in this case. Towards solving this problem, we propose a query-guided localization framework that has two components: a proposal graph generation and structure representation learning. We first generate a set of 300 region proposals and then create a proposal graph with region proposals as nodes and spatial semantic relationship between them as edges. So we can use a fully connected proposal graph, but it contains an order of n square edges, which is both computationally expensive and definitely not required. And since the relevant number of edges is determined by the plausible set of visual semantic relations between the objects in the scene, which in turn is much smaller than n square. So in this work, we use a relation present in the query scene graph to keep a small but relevant set of edges. After scoring each edge with all the relations, we keep that edge only when it scores high with at least one of the relations. We then construct a larger Visio-Lingual graph after adding auxiliary edges from the query graph nodes to the proposal graph nodes, and then learn the representations of the nodes by a three-step message passing. The updated representation of the query nodes are then scored with the representation of the region proposals to localize the corresponding objects. We designed the baselines to understand the importance of both the structure as well as the relations present in the query scene graph. So we also created a split of the visual genome called VGFO with 150 objects and 40 visually relevant predicates. Additionally, to study the grounding of unseen objects, we created another split called VGPO, where 25 objects are removed from the training data. Our method gives state-of-the-art results on many publicly available benchmarks such as CocoStuff, VGFO, and SG. Similarly, the localization of the unseen objects is also improved significantly. And these are some of the visual results. To conclude, we extensively studied the problem of scene graph localization in natural images and proposed a localization framework with three-step message passing. The proposed framework significantly improved localization of both seen and unseen object categories. To know more about our work, please visit our project webpage. Thank you very much.